Hello friend, I am Naren, your friend, your host. Today I'm back with another DevOps interview video. In this video, we're gonna talk about how we can use Terraform, GitHub and deploy AWS resource where we can deploy our application. So without a delay, let's get started. First, we can talk about our task definition. So here a company want me to deploy Nginx application with AWS application load balancer and perform the CI/CD operation is. So what is the objective? We have to design and implement an automated DevOps workflow to deploy an Nginx container application on AWS infrastructure with high availability and scalability. Whenever you hear the term high availability and the scalability, make sure there is the auto scaling. We have to configure the auto scaling for that. So let's understand the requirement. Okay, company want to infrastructure provisioning using the Terraform. We have company want to provision EC2 instance to host the Nginx container application, and we also configure application load balancer to distribute the incoming traffic only to help the instance. Apart from that, we have to implement an auto scaling group to dynamically scale instance based on the traffic demand. So the company want us these three resources, and EC2 instance should be launched by auto scaling group. Later in the demo section I will show you how to do that, but overall we have to deploy three resources of AWS and associated extra resources that's associated with these three instances. After that, company wants you to either write a Jenkins pipeline or a GitHub action. Now we are going to see the GitHub action in this video. In the GitHub action, they ask you to build and deploy the Nginx container application automatically. That's fair enough. And also integrated Terraform execution into the pipeline for the infrastructure provision. Meaning you have to write a GitHub action where you can running a Terraform and build and deploy Nginx container. And all the AWS resource should be provisioned using the Terraform. And we also make sure that pipeline support deployment scaling and update seamlessly. That's okay. And the third requirement is security and secret manager. Store sensitive credential, AWS access key and other related credentials securely in AWS secret manager. Configure the pipeline to retrieve the secret securely at runtime. Now this requirement is tricky. Why is tricky? Since you want to you want to provisioning the infrastructure using the Terraform. When you are provisioning the infrastructure, you must configure AWS credential before you are triggering the Terraform. From the AWS secret manager, you can retrieve the AWS credential by running the AWS command. Meaning company, maybe the organization want you to confuse here, but I will show you a tricky part where we can using this we can retrieve the secret manager. Although it's a mistake, maybe the interviewer want you to identify this issue, and maybe further after you submit your assignment to them, they want to keep discussing on this point. So be aware, whatever requirement mentioned here is not 100% aligned within the correct way. Maybe company want or the interviewer want you to discuss this problem. If you not, then maybe interview will ask a question to further understanding your area or your expertise on this. Okay, So what is the deliverable? We have a Terraform code for provisioning AWS resource. Okay, you have to write the Terraform code, and you have to write a Jenkins file or GitHub action for workflow of YAML in the CI/CD automation, and document outline setup execution. The third steps can be avoided because you they when you are working in the organization, of course whatever you write you have to document in a proper way, but for the interview process, documentation is, it doesn't really matter. So let's understand the flow. So I'm going back to the PPT where we can understand the flow of this process. So first of all, assume that you have a Git repository, okay, and developer commit something on the Git repository. Once you commit something or developer commit something in the master branch of your Git repository, a GitHub action will trigger. Once GitHub action will finish, you will deploy your application for the end user. Now let's talk about what are the contained in our GitHub action. Of course we are calling the Terraform, we are using the Terraform for provisioning the resource. So these are the AWS resource that we are provisioning. Our requirement is to create a secret. So for that we have to create the AWS CLI credential in this AWS secret manager. Then we have to configure the application load balancer, and then we have to configure the ASG for high availability and the scalability, and also fault tolerance. ASG is nothing but the auto scaling group, which is generally make sure that your desired number of instance is always running, and if there is a high volume appear on your website or your application, ASG will make sure to launch new instance. And then from the ASG we have to launch one EC2 instance. Hope you understand this workflow, and if you not, write your query in the comment and we will discuss. So now let's move to the console where we can open the project and discuss what I have built for this interview round. Let's go to the command prompt. In the command prompt I create a folder, and I will open this folder in Visual Studio Code. So now you can see my Visual Studio Code. We can close everything, and then in this project I have a GitHub workflow which is under in .github folder inside the workflow development.yaml. And if you have noticed, my project is I create a project one directory and then put the GitHub flow outside, because the GitHub flow should be exist on the root directory. So when you are push this project, then GitHub automatically identify your flow and start triggering your flow. In the project one folder, we put the file diagram. This is the diagram that we are going to execute, and apart from that I have a main.tf and provider.tf, and I also put the task definition in the PDF form. It will not open here on the Visual Studio, so but you can definitely open this task definition on the browser, and later after the video or maybe in the description I will add the GitHub URL, so you can also refer the project in the my GitHub repository. Now let's open the provider.tf. In the provider.tf we are not defined to we keep it simple. In general we have two things in the provider, generally two or three things in the provider. One is the required provider, that you have to configure that which provider you want to use for this to provision the infrastructure. So we are using the AWS, and this is the minimum version, and whatever the highest version we have to download that specific AWS plugin. and then we are configured the AWS provider, the default region, and the third item should be the backend. Here you can also configure the backend if you want to put your terraform.tf state file into S3 bucket or somewhere else. Okay, so let's save it this our tf file, and now let's take a look of our main.tf file. Now I will let's do this for easy understanding for us. Now for this video we have to create multiple resources as per the requirement. Now since we are going to create auto application load balancer, and we are also creating the auto scaling group, so for that we need VPC and we need a subnet, and our auto scaling group will create a launch template that is nothing but it will create a instance for us, and when you are creating an instance you need a AMI. So there is no requirement to create a new VPC or a dedicated VPC for to fulfill this requirement. So we considering to getting a default VPC. Every region in AWS, every region you will get a default VPC, and default VPC come with the default subnet. So we are leverage that feature and we are skip creating a new VPC for this task. So data resource will be used to getting the existing resource. So we are using data and we are specifying we want to get the VPC, which VPC is a default name, and we will saying default is true. So it will give us a default VPC, and on in the subnet we will filter the subnet ID. So what we are saying that get the subnet and filter is here is the VPC ID, and the VPC ID we have to provide the VPC ID, and it will return all the subnet that exist in that VPC. After that we are filter the Ubuntu AMI. So this is how you can filter the AMI from the available AMI in the marketplace. So we are going to use Ubuntu Jamie 22.04 AMI, and these are the filter setting, and of course we also need another filter, that virtualization type should be HVM and owner is this, and then this code will return one AMI ID to us. Fair enough. Now since you maybe wonder, I have created the key pair. Key pair generally is not defined in the requirement. We can simply ignore it, or if you want to analyze or if you want to debug if there is a problem in your code and you want to debug this code by connecting the instance, connecting the EC2 instance, you must create or associated a key to the instance, and also you need to expose the 2022 port for SSH logging. So I want to debug in case something is not going as per my expectation. I have to connect to the EC2 instance, so I create the key pair. Creating a key pair is very easy. So you have to specify which private key that we are going to use TLS private key, and give the name and algorithm you have to specify. I specify here RSA, and RSA bit is 4096, and then we can create a key pair. Then we can create a key on the AWS. We can assign the key name, and public key we have assigned the public key getting from that this resource, and we can say key RSA and public key OpenSSH. This will create the key on AWS. You are creating a key on AWS, you have to download a local copy for the key. For downloading you have to a resource called local file. In the local file you can specify and you can add the content which you want to store in your local file. So I want to get the content of TLS key RSS private key PAM and store this content into my current project. You can say current path and then this key. This is simple enough, and if you don't want, you can simply ignore it. But if you want to debug the debug, there is only one possibility that you can debug your code or your flow by connecting to EC2 instance. Because if the, let's say if the container is not created on your EC2 instance, you have to connect the instance by using the SSH logging mechanism and use this key. So it's up to you. Okay, this is nothing mentioned in the requirement, and it's up to you. But interviewer definitely, when you are mentioned this, you are specified this, interviewer will ask a question about this, that why you need a key. So you have a fair enough answer that you can simply explain that, okay, if something is not working as per my expectation, I can connect to the instance by using this key. Okay, now let's come to the main requirement. We have to create, okay, we have to create the security group for the instance and for the ALB. Okay, so first let's create the security group for ALB. So in the ALB, you can specify the security group name and then specify the VPC ID and specify the ingress rule and egress rule. Egress rule probably the same for your case, also the same. I want all the traffic should be go outside from the instance, and ingress is something is coming inside your instance, meaning you as a user want to access something from something inside the instance. That is the meaning of the ingress, right? So we want to open a port 80 and from port 80 and from to port 80. After that, you have to create this is security group for ALB. Okay, and we are creating a security group for instance. Now, since we are accessing this instance from the load balancer, okay, so remember, when you are accessing the instance from the load balancer, your ingress rule, you cannot directly assign the ingress rule uh, like this. Okay, so the port 80 should be accessed from the ALB. So meaning something like your flow is something like you as a user send a request, okay, to access the application. That application request goes to your ALB, and then ALB forward that application, that request, to the target group, and the target group will send the request to the EC2 instance, and then EC2 instance responds that request to the target group, and then target group send back to the ALB. Such kind of the flow we have. Now I have added the ingress port 2022 here because I want to access the I want to enable the SSH logging. Okay, and now egress will be the same, and here we are giving a permission ALB to EC2. So we have a create a security rule, and this rule will be assigned back to this EC2 instance by using its ID, right? So what we are saying that we want the ingress rule from port 80 to port 80, and source security group ID. Here we will provide the ALB SG, meaning only ALB SG, only ALB access, only ALB send a request to this instance. Okay, and if you still have a question, I strongly encourage you to write the comment, because if you write the comment, it will also help me to understand whether I'm spending this time for creating this video. And if you write the comment, then I can understand whether you are aligned with me, or maybe you have a different thinking, you have different questions. So I will also try to answer your question. So writing the comment is very beneficial here. So we are assigning this ALB to EC to access and giving and make sure that ALB send a request to EC2 instance. Okay, now let's create the load balancer. For the load balancer, we have to create three things: application load balancer itself, and a target group, and a load balancer listener. Okay, so application load balancer receive the request, send it to the target group, and the target group will act accordingly. It will send it to the EC2 instance. So creating a load balancer in the Terraform is very easy. You can give a load balancer name, then load balancer type. Here is the application type. Basically there are three types of the load balancer: application load balancer, and network load balancer. Third one is gateway load balancer. So application load balancer is used mostly for HTTP and HTTPS and WebSocket. And network load balancer will be used for TCP, UDP, and some high performance things. And for gateway related load balancer is used for firewall, DNS, something like that. So we are going to use the application load balancer, and security group we have created above here. For load balancer, this you can see ALB SG, and we have to assign that security group here on the load balancer, and we give the ID, and then it will be assigned a security group for the load balancer. And subnet, of course we have to define which subnet your load balancer is exist. So you have to, we already get the existing subnet from the existing VPC, so you can use data.aws subnet. This is the name of your function that you created above, and then default, and then IDs. Now let's take a look about the application load balancer target group. Now in the name app.tb you can assign any name. This is the common, and we want to receive and send like port 80 and HTTP traffic. VPC ID is this, and we have to check the health check. We have to ensure that in the requirement is mentioned that only a healthy instance should get the request, right? So we have to do the health check path. You can specify the route, and these are the parameter for your health check, like how often you are checking. Okay, it's all the these two are in the in the second. And then we have to create a load balancer listener. For load balancer listener, you have to create the load balance ARN. This ARN is nothing but you can get it from the app application load balancer that you have created here. Okay, and listener, of course we have to listen port 80, only the 80 port we are going to listen. And then we have, if you have WebSocket configured in your application, then maybe you have different port number. Okay, and then protocol is HTTP, and this is the default action. We are just simply forward the request, meaning you as a user sending a request to the ALB, and ALB forward this request to the target group, and then target group send this request to EC2 and get it, and vice versa. Okay, that is the load balancer. And at last we have to define the auto scaling group. Auto scaling group is responsible for creating your instance from your launch template. So when you are creating an auto scaling, you have to create two resources, at least two resources. One is the auto scaling configuration, another one is the launch template. Launch template is nothing but a blueprint that what exactly how your instance is going to create it. Okay, so let's create the auto scaling group. In auto scaling group, you can, of course, you can give a name of your auto scaling group. I put it here app-ASG. You can choose any name. Okay, desired capacity meaning how many instances you want to keep running. I choose one by default. If you have, if the interviewer mention this information in the requirement, then you have to define desired capacity accordingly. Otherwise one is good enough. And then max size is how many maximum, how many max count of instance you want to launch whenever the spike goes up. Okay, Then I said maximum instance is 2 and minimum is 1. And then you have to provide the subnet ID as a VPC zone identifier. Okay, remember this name, VPC zone identifier, as nothing but it will keep the subnet IDs. And then you have to give a launch template ID in your auto scaling group. Launch template we have created below, we will talk it later. So it's just getting the ID of your launch template and assign it. And version, of course, latest. Remember, you have to use this dot, dollar sign and L capital should be in the latest version of the Terraform. And then you have to get the target group, because at the end of the day, target group is responsible sending the data to your ASG, and then ASG will act accordingly. So we have to assign the target group ARN. And also this is the extra things if you want to create the tag, but I suggest you can create, so it will help us to easy to understand or filter it out on the AWS console. Now let's discuss about the AWS launch template. AWS launch template, here you have to give your instance type, instance AMI ID you have to provide, and key if you are using. If you are not using is perfectly fine, and network interface we have to specify, and you can get it from AWS security EC2 SG ID. This one is EC2 SG ID, here we already defined. So if you can search here, copy and paste, then you can, oh, there are a lot of things here. So here this network interface we have to specify. Okay, after you specify the network instance, this is become your security group from the launch template. And then this is the important part. User data is the property which get initialized when your instance first time launching. Meaning when you launch the instance, an instance will start, this script will execute. And this script you need because you are using a base AMI of Ubuntu. So because we are going to deploy a Docker container, so we have to install the Docker first in the our instance that we are launching from the auto scaling group. So you have to, I'm just, this is nothing but installing the Docker in the EC2 instance, and we are assigning the permission to our default Ubuntu user to run the Docker command. And then we have to deploy our Nginx container. By doing this, it will be pull the Docker image, latest Nginx image, and it will be run the container after that on port 8080. That's it for the Terraform. Now let's save the file, and we are going to commit, and we also have write a GitHub action. Once you push the commit, once you push these changes to your master branch. Why master? Because in the GitHub action we specify that this GitHub action will only trigger if something is pushed or commit in the master branch. So that's why I mentioned the master branch. But if you have different branch, or your interviewer asks a different branch, then you have to specify the branch name here. Okay. Now let's talk the problems that interviewer specify early in the description, that you have to create the secret management, the secret keys in the AWS secret manager. Now since we are writing this, I will get back to you on this environment variable. So you can see we are executing these steps. Okay, these steps required to configure the credential, right? If you, and you generally running the AWS config command, right? So when you writing AWS config command, or let's say if you don't want to configure this, you have to perform the Terraform, right? Terraform perform, that means when you run the Terraform command, you have to configure the AWS credential. Okay, since we don't want to be exposed parameter here, or we don't want to expose the our credential by running the by specifying the variable value here on the command line, because it will be security purpose it is not a good idea to specify. So we have to configure this, and in order to configure we have to get this key, and in order to get this key from the AWS secret manager you have to run the AWS command. An AWS command in this machine will not working until and unless you configure the credential of the AWS. So this is the tricky part, that interview want to mention this, and maybe after you complete this exercise interview ask the question. So instead, of course, I have providing the comment section where you can get the it get the AWS credential from the secret manager from AWS, but I suggest you can create these credentials or create this uh, key value pair in the GitHub secret. Okay, GitHub, creating this key and value pair in the GitHub secret is very easy, and then we will get it from the GitHub secret and set it over as an environment variable, and later in this code we can also replacing this value from the AWS secret manager. So you have to specify this, and when the interviewer asks these questions, and or if we not ask, then you have to specify your when you are explaining the code you have to explain this that why you are doing this. Okay, so now let's take a look how you can create the secrets key in the GitHub. So I will go to the GitHub here. So this is my repository DevOps project exercise. You do not have a permission to see the setting, but when you create a repository by yourself you have options settings here. You can go the settings here. In the settings you can see the options secret and variable. Go here in the action, you can create a key and value here in the new repository secret, similar like I have created 3 key and assign the value to this key, and later in the CI/CD pipeline we are getting this key using the secret function dot key name. Okay, and this part, if it is still not clear, write a comment, ask me question, and I'm sure I will answer your comment. Okay, and once we have get the secret key, we get it, set the environment variable as same as the key name. It will easy to, you can change any name, is okay, but better to change use the name standard format, so it will be easy to remember. Now we are building our pipeline. Okay, so we are provisioning and deploying container application run on Ubuntu. So here we are telling GitHub, hey GitHub, look, we are running a GitHub action and you have to create a latest Ubuntu image container, and in this container run these steps. So first we are check it out our repository. I'm using the predefined action. You can also use from the GitHub marketplace and GitHub teams already created, or GitHub community, I would say GitHub community already created useful actions that you can use directly. Of course, if you don't want to use, you can also define git clone and repository URL by yourself. Okay, but better you can check it out, this code, it will really very handy, since interviewer did not mention it specifically, so you are feel free to use it. Okay, and when he asks a question about this, you can discuss about this. Okay, and you can show how you can cloning. Okay, that's also fair enough. Now since we are running a Ubuntu latest container, we are not sure the AWS CLI is installed or not. So for that we are first checking whether the AWS CLI installed or not. If it is not installed, we install the AWS CLI, and if it is installed, we will happy to printing the AWS CLI version. Now let's configure our AWS credential. You can configure, of course, basically there is a 2 file. If you are working with the Terraform already, there is a 2 file that you can configure. One is the credential file, another is the configuration file. Credential file is creating keeping your key and secret access, and config file is keeping your region and output can be a simple text format, or you can keep it as JSON format. JSON format is best when you are working automatically. Okay, when you are setting and when you are working on automation, keep it the output format JSON. And now here is the tricky part. You can also show a mechanism how you can get the secret from the AWS. So here you have to run this command, AWS secret manager, and then here is the get secret value. Specify the region, which region you want to get the secret, and then secret ID, and here is the my AWS credential. Now creating a secret, before getting the secret from the AWS, you have to create the secret. So creating a secret is very easy on the AWS. Go to secret manager, and here is the secret manager. You can simply open it and store a new secret, similar like I have stored one secret, and in this secret I have a 2 to 3 key that we are going to use in the code. Okay, so if you want to create a secret, you can go to the AWS secret manager. Remember, secret manager charged by the AWS, so you use wisely, and then store a new secret by clicking on this. If you have a secret for RDS, something like, go specific, otherwise better to go other type of the secret. Specify your key and value, and then add row or something, and then it next. When you click on the next, it will ask the name of the secret and other few details. Okay, and you can configure this one. So this is the way how you can create the secret. Okay, after creating a secret, and we also configure the AWS CLI. So let's make sure that our AWS CLI configured correctly. Okay, if you enable this command, then if AWS CLI is not configured correctly, then this command will give the error. Or if you are not using this one, then you have to run this AWS STS get caller identity. This will return a value of your caller identity, and if there is a problem in your configuration, then it will be throw error. Now let's install the Terraform, since because we are we are working on the Ubuntu container, and in this container there is no Terraform installed. So it's your responsibility to install the Terraform. So I'm installing this version of the Terraform. Perfectly fine. You can just get the code online or get it from here. That's perfectly fine. And then we have to run the Terraform init command. Where is our Terraform file? Our Terraform main.tf file is in project_1. So we have to set the working directory. If you have the main.tf file on the root folder of your project, no need for this working directory. You can directly run the command, and we are running the Terraform init command. Similar way, once the Terraform init gets success, we are running the Terraform plan. Of course, we have to set the working directory for the plan as well. And similar way, we have to run Terraform apply command. Since you are writing the pipeline, so do not forget this auto-approve flag. This flag is very helpful to avoid asking the prompt confirmation. So if you not specify and run your GitHub action, it will be waiting for you to saying yes, and you cannot typing because it's running out of your control. Okay, so better use the auto-approve flag. And after applying, we are waiting 6 to 7 minutes to make sure that all the resource launch successfully, and then we will access the application. And after accessing the application, we should destroy our resources. Okay, we should not keep our resource running. It will be charged money, and your bill will get increases. So always remember, once you provide the script to the interviewer, you can destroy, make sure you destroy all the infrastructure. If interviewer asks you that why you did this destroy without even asking you, it's a good sign that you have to explain that why you did this action. Just simply tell that, okay, I don't want to I don't want to resource keep running unnecessary, so that's why you choose the destroy. So this is our GitHub pipeline. Now we have saved the code. Go to the console. Let's say git status. We did some changes. Git add. Now let's say git commit m, and then we are saying push something on master. Okay, and then when you commit, git push origin master. Once you push your change it in the master, and then you can go to your repository. Here in the repository you can go to the action. You can see one action has been automatically triggered, something related to your commit, right? Push something on master. Go inside this, and this is this where you can see your step name. Now you can go inside. It has been, check out the repository, install the CLI. If it is not exist, configure the AWS credential validation. AWS get success, meaning AWS credential gets successfully configured. Install Terraform manually. Installation of Terraform is done. Terraform init command is done. Terraform plan is executed. Now it's running Terraform apply. So here you can see, you can now it will creating all the resources. So this will take some time to create the resource. Okay, so now you can see all the local key and template, and the application load balancer is still in creating mode. While it creating, we can go to here. Let's say we can go to EC2, where we can see our application load balancer. Okay, so you can go here on load balancer. We can open in a new tab. Let's close this one. So now you can see here on the load balancer one app ALB provisioning. So if you go instance is not yet created. Okay, so we do, okay, instance is running because the ASG is already created, and ASG create the our desired instance. Okay, so now let's talk about the load balancer is still provisioning, and that's good sign. And we can also go to the auto scaling group, and we supposed to be have one auto scaling group, that app ASG. You can go inside. You can see the launch template ID. Launch template has been created successfully. You can see a launch template here. So this is our launch template that used by the auto scaling group. So if you go detail here, then you can see all the details. And instance management, you can go here. It will be list one instance, and that is the healthy instance. Okay, so that means your instance has been created by ASG. If you see the instance detail here inside the ASG, it means it get created from ASG, and the status is healthy. That's fine. Now let's go to EC2 instance, and we have to wait it complete the all status check. Basically 2 status check it will be complete. Okay, once the status check is complete, it will again take maybe 1 or 2 minutes to installing your Docker and all this stuff that you specify in the user data. Okay, and let's go to the load balancer. So load balancer is here, is load balancer. Let's see, it's created. Okay, load balancer is active, and we can reference. If you can see the details, then you can see all the AMI and all the VPC details and all here. Now listener rules and listener rules will be created here. Is supposed to be have one listener. Yeah, that is the HTTP 80. Okay, and network mapping, you can see the network mapping here. Resource map is the good way to understand that we have one listener, and then is forward the request to the target group. Target group forwards request to the app. This is the target instance directly, and then it will be moved to the request here. And yeah, that's correct. So here is the DNS name. This DNS name you can access your application. I copy the DNS name. Now we are in a waiting stage. Okay, that's fair enough. And if everything is goes well and your installation, Docker installation and other installation that you put in user data, if that part is done successfully, then you can access your application here. So let's enter to see whether we can access the application or not. Now we can access we successfully deploy the Nginx container using ALB, auto scaling and EC2 instance. Okay, so you can see your instance is probably status check has been completed, so that's why you are able to access the engine application. So this is how it's working. Okay, so one more thing we have to check here, that you have this subnet. So let's go inside this subnet to check that what are the inbound rule for the subnet and outbound rule, because we have configured that, right? So we are here in the subnet. So you can this is the route tables. We go to this subnet here, but we don't know which subnet we are using. So again we have to go to the load balancer and network listener security. Yeah, this subnet we are going to use. So let's go to this subnet, and in this subnet you can see we have an inbound rule for 8080. Okay, and outbound rule for all traffic is allowed. Okay, so this is how it is configured. Now let's took our pipeline. So this pipeline will keep waiting for at least 6 to 7 minutes, and I don't want you to wait for here for keep 6 to 7 minutes. So pretty much we have done successfully everything, and we have our pipeline is working fine. All the resources has been allocated, and one small thing I forget to mention, I also keep the output here, and you can see the DNS name, you can copy the here, and in the middle you can see star star, because we are getting the data from the secret GitHub secret, and we are putting the data directly here, so it will be not printing the data in the plain text. That's why you are seeing the region is star star. So if you want to print, I suggest you can do not use the AWS, you do not use the AWS environment variable in your pipeline, directly define the region here, so it will be getting the region from there. Okay, so I think that's it for this video, and I hope you like this video. If you like, hit the like button, subscribe my channel for further video, and I will also try to record a video in local language. So those who are really looking for a video in the local language, they can wait for my upcoming video, and we will soon, probably tomorrow or day after tomorrow, we will have a new video in the local language. Thank you very much, have a great day, and see you in the next video.